Our focus is going to be on lesson 5 of chapter 5, which is looking at or digging into simplifying algebraic expressions. A couple things that we want to think about when we are talking about simplifying algebraic expressions. Going back and reviewing the term algebraic. Remember, algebraic is when you are looking at numbers, variables, and operations that go with it. Operations could include addition, subtraction, multiplication, division, could be exponents as well. The other thing is we're going to be focusing on expressions. Remember, expressions are when you are working with numbers and or variables and operations that do not have the equal sign with them, okay? We're not having them equal something yet, so we're focusing on just the expression and not the equation, okay? Something to take note here as you take a look at lesson 5, there are 4 vocabulary terms that are within this lesson. So please just make sure that you do take some time within this lesson to fill those in your vocab web. I am going to talk about them real briefly here just for a second, just to kind of give you an overview of what they are. When we talk about terms, okay, in math when you're talking about a term, basically you are talking about each part, okay, that is within that expression. An expression could consist of one term, it could consist of 2, 3, 4, 5, 6 unlimited terms, okay? But you're talking about each part, and as we get going, I will break that down a little bit more. Next thing we're focusing on is like terms, okay? Like terms are just like they are, or just like they sound. You're going to be focusing on the parts of them, but you're focusing on the ones that are alike, okay? So they have to be like each other. For example, if I have a situation where I have 3x plus 2y. Okay, those would not be considered to be like terms for the simple fact that this one has a variable of x and this one has a variable of y. Okay, therefore they would not be like terms. An example that could be a like term would be if we have 2x plus 3x. Okay, because both of them have the x with them, they're considered to be like terms, which means that we can combine them. So if I have 2x's plus 3x's, that's going to be the same as 5x. And again, we'll get more in depth in that as we go. Next one is going to be your constant. Okay, when we're focusing on constants, constants are going to be your terms without variables. Basically, they are your numbers that are by themselves. Okay, and then simplest form. We've talked about simplest form before, but when we're talking about simplest form, what that means is basically there's no more like terms. We're not able to simplify it down anymore. It's going to be in its reduced state is what we could say. Okay, so we're going to go ahead and take a look at page 387. So if you would turn in your books to page 387, we're going to get started on this page today. Okay, one of the things that we had talked a little bit about before on the first page with your vocab, okay, was term. Remember, that's going to be each part. Okay, so something that you may want to circle or identify in your book would be a situation that your terms are going to be each part. Okay, like terms are going to contain your same variable, all right, and they have to go to the same power. What they mean by that is if you have x to the second, you can only combine that with another term that has x to the second. If I have an x to the third or x cubed, I cannot combine that with an x squared term. The other one is going to be your constant. Okay, constants can be like terms, but again, basically those are your terms without variables. So when you have a situation of, let's say, 2x plus 5, okay, my constant in that is going to be 5 because that's my term that does not have a variable with it. Okay. Taking a look here at a specific situation that you're going to notice in your book, they have given you the expression negative 4x plus 12 plus x. So it technically has 3 terms or 3 parts to it, and you can see that they've identified those there. Okay, your constant is going to be the number 12. Again, that does not have a variable associated with it, so therefore it's the constant. Your like terms would be a negative 4x and x. They are considered to be like because they both have the variable x. And your powers are the same. Both of these would have an exponent of 1, so therefore you can combine those. The other thing that I want to mention and kind of review here a little bit is your coefficients. Remember, coefficients are your numbers that are ahead of your variables. So in that case, you would have negative 4 as a coefficient. This one, as I take a look, I don't see it, but the number 1 would be there, so your number 1 would be the coefficient. As we take a look at example one of the expectations of this lesson that you're going to be able to do when you are finished is to identify your terms, your like terms, your coefficients, and your constants, okay? So they're giving you the expression 6n minus 7n minus 4 plus n. So first of all, you have to identify your terms, okay? So terms are your parts. So you're looking at 6n, negative 7n, be careful with the subtraction sign, negative 4 and n, okay? So we've pulled that apart, we've said our terms, and we have those there. Next thing we're looking at like terms. So what are things that we can combine? So in this case, we know we can combine 6n's and negative 7n's, so they've grouped those together. We can also group this n together, okay, with it. So those would be the three that we can put together. Negative 4 I cannot group with anything because it does not have an n behind it, and I also do not have another constant to go with it. Coefficients, again, are your numbers that are ahead of your variables, and I talked about this earlier. If I take a look up here, the number ahead of the variable is a 6. Here your number ahead of the variable is negative 7, and here your number ahead of the variable would be 1 because I have 1n. If it helps you to draw that 1 in there, please feel free to do that. Okay? And then your constants, again, are going to be your numbers that stand alone. There's no variable tied with them. So negative 4, okay, could be considered to be the constant. Again, you're going to be identifying those 4 pieces. Please make sure as you write them out, you identify terms, like terms, coefficients, and constants. Don't just put numbers down there, because if you do, then we're not exactly sure if you know which one is which. Okay, so your examples that you have here, I would like you to take a minute to pause your video and then come back and we'll check your got it problems A and B. All right, as we take a look at got it problem letter A, again, first thing that we're going to be doing is looking at our terms and identifying our terms. So when you take a look at this, you're going to notice that you have 4 pieces in this, all right? I've got 9y, I have a negative 4. If it helps you to underline or circle what you have, that's fine. Next term would be a negative 11y, and then your last term is going to be 7. So next to your terms, those would be the 4 that you would have. Next, after terms, you're looking at like terms. Your like terms in this situation, again, are things that you can combine together. So my like terms I would have would be 9y and negative 11y. And then I can also combine together negative 4 and 7. So there's 2 sets of like terms that you would have. Next we have coefficients. Those are your numbers that are ahead of your variable. So looking at where your variables are, I know here I have a 9. So my coefficient, one of my coefficients is going to be 9. And my other coefficient would be a negative 11. Lastly, we're looking at constants, again, those numbers that stand by themselves. So my first constant is going to be a negative 4, and my second one would be negative 7. Hopefully you were able to come up with those as well. Taking a look at letter B real quick here, my terms, again, I have 4 terms. So when I'm thinking about my terms, and I'm just going to abbreviate here real quick, I have 3x, 2, negative 10, and negative 3x. Again, there's 4 parts to it, so you have 4 terms. Next thing is like terms. So what can I combine together? My like terms in this case, I'm looking at 3x and negative 3x. Okay? Then I would also be able to group together 2 and negative 10. So those would be considered to be like terms. Coefficients, numbers that come ahead of your variables. So my coefficients are going to be 3 and negative 3. Again, those are my numbers that are ahead of the variables. And constants are the numbers that stand by themselves. So in this case, my constants would be 2 and negative 10. Next piece that we're going to look at is simplifying algebraic expressions. So we're going to be talking about how we can put them in simplest form, again, using our distributive property to combine our like terms and put our like terms together. They have a couple examples on the top of 389, example 2. They want us to write 4y plus y in simplest form. Again, 4y and y are like terms, so we can combine them. I technically have 1y here. So technically I'm thinking 4y's plus 1y's, which would give me 5y. As I take a look at number 3, or example 3, I have 7x minus 2 minus 7x plus 6. So we want to look at what can we combine. I'm looking at my x's. Okay, so I have 7x's minus 7x's. So technically that's going to wipe them out. They're going to cancel because 7 minus 7 would be 0. Then I have negative 2 and 6. I can take negative 2 plus 6. Negative 2 plus 6 would be a positive 4. So when we combine our like terms and put it in simplest form, your answer would be 4. As we take a look at our got it problems here, we'll kind of work on these together. If you want to try them and then check, you're more than welcome to pause and do that. Taking a look at letter C, I've got 4z minus z. Technically there's 1z there. I can combine both of them, so 4z is minus 1, so 4 minus 1 should leave me with 3z. As I take a look at letter D, my like terms are negative 3 and 3. Negative 3 plus 3 would be 0. What do I have left? I have the number 6 left. Letter E, I have 2g minus 3 plus 11 minus 8g. Okay, I can combine my g's. So I'm thinking 2 minus 8, which would give me negative 6g. And then I know I can combine negative 3 and 11. And negative 3 plus 11 would be a positive 8. So in simplest form, we have changed all three of these expressions. You're going to notice sometimes you have, something as simple as 3z where you have a number and your variable. Sometimes you're just going to have a whole number, and sometimes you have a combination of numbers, variables, and operations. The next part is taking a look at real life situations where you're simplifying. So you can take some time and go ahead and read through example 4. Take note. I'm going to go ahead and take a look at example F so we can work on that one together. It says, write an expression in simplest form for the cost of the jacket in example 4 if the markup is 8%. Then determine the total cost after the markup. So if we take a look, okay, if I go back up here, on a 5% markup, I used 5 cents times J. So if we think about what we're doing on the bottom one with an 8% markup, we probably, instead of using 5 cents or 5/100ths, we would change that to 8/100ths there. Okay, so when we're going back down here and we're going to write an expression, okay, technically we should be thinking that we're going to multiply 1.08, okay, and then times our J again because of the jacket. Again, we were thinking 1J plus 8 cents or 8/100ths times J. When you add those together, you're going to come up with this. So this would be your expression. Okay, then determine our total cost. So technically we should be thinking 1 8/100ths or $1.08 basically times the cost of the jacket, which was $35. And when you plug that in or multiply those out, our cost of our jacket should be $37.80. So there's taking our skill of putting our expressions into simplest form and applying them to real life situations. Okay. If you would, take a look on page 390 at the top, example 5. Okay, they give you a situation, you're buying some t-shirts for $12 each and the same number of CDs for $7.50 each. Write an expression in simplest form. Okay, please note that they want that in simplest form. That represents the total amount spent. Okay, so we know that we are buying t-shirts for $12, so $12 times our amount of t-shirts, plus we're getting CDs for $7.50. We're getting the same amount of CDs as we are t-shirts, so we can use the same variable. We can combine those, so we're thinking 12 plus $7.50, which would give us $19.50 times X, or the number of t-shirts and CDs that we're getting. So there would be an expression in simplest form that would represent our total amount. Okay? At this time, you can go ahead and try got it problem letter G on your own. I will go ahead and write down answers, and then I would like you to go ahead and take a look at your web page, and you're going to start on your practice problems, which will be on page 393. So please follow the directions on the web page. Okay? Again, if you're taking a look at letter G, as we're working through this, we are supposed to write an expression in simplest form that's representing our total amount of money you and your friend have. Okay, so you and your friend means you have two people. Your friend has $50 less than you. Okay, so you're going to take your money, we'll say your money is X, okay, plus you're talking about the money that you have, but the situation is your friend actually has $50 less than you, right? So you're thinking your friend is going to have $50 less than you. So this is the amount of money that I have. This would be the amount of money that my friend would have. When we combine this in simplest form, I can combine my x's. So I have one x plus another x, so technically I have two x's, and then I'm subtracting 50. So your amount of money, your expression would be 2x minus 50.